Hello, everybody, and welcome to. I don't know what to call this, but this is my stream as I'm going to be starting to look at the protocol that sits under Blue Sky. I've been looking at it a little bit yesterday and a little bit today, trying to get oriented with what's going on. And I figured, as I dig into it and give some of my thoughts, might as well do it live. It's very weird for me to be doing this again. For those who don't know, I hosted a live stream weekly-ish for years around Kubernetes called TGI Kubernetes. And when I retired a little while ago, I gave that up. And so, it's a lot of work doing that live stream, but I love doing this type of thing where I engage with folks and say hi and dig into new technologies and really just sort of, show how I'm thinking about things, how I'm approaching things. It's a lot of fun. So, hey, Brad, how's it going, man? And there's a whole bunch of folks in the comments. I should have YouTube set up such that when people watch the replay, they're going to see the comments, which is great. And if you guys have any questions for me, go ahead and ask. I think, I'm happy to answer whatever. By no means am I an expert in the stuff that I'm going to be talking about here. I think there's probably between Brad and Ryan, who I see is on there. I know they've been looking really deep into this stuff. But for me, this is, maybe a little bit of a random walk of somebody who's new to a lot of these ideas. And hopefully it'll be used to helpful for others. Hey, Julia, how's it going? Good to see everybody on here. All right, so let me just sort of outline what I want to do today. So let me go ahead and switch to my screen. And I got some cool background music going on here. Oh, wait, why is it showing that? So, oh man, freaking. My screen cap, it was working like 3 seconds ago. Seriously. Oh man, why is it not showing my latest? This is like a snapshot of what it was seeing. See, I can do just me, the screen cap. Okay, this is a pain in the butt. Let's see. What happens if I do this? If I go through, maybe this will reinitialize it. Okay, so I think... All right, now we got a mouse cursor. We can see stuff. Cool. OBS. Yeah, I had to set it up from scratch. But hopefully things are looking good. All right, so the main thing that I'm going to be starting from is this atproto.com site here. This is something that the Blue Sky folks put together to talk about the underlying protocol that they're using. And let me give you a little bit, I think most folks here probably heard about this from Blue Sky. Blue Sky is a Twitter-like service. It's built on an underlying protocol which is distributed, which is really interesting. With the idea here, the goals out of this is to have a level of federation, which I think has a lot in common with what you're seeing in Mastodon. But there's a couple of things that they're doing that are different and I think improved over what we're seeing on Mastodon. Yeah, we got some music now. I found these are supposed to be, totally royalty-free things. I figure, if we're going to be sitting here for a while, it's good to have a little bit of music going on in the background. One of the things that I think is most interesting here is this idea of account portability. With Mastodon, if you move an account from one server to another, it relies on the previous server to be able to actually forward connections through and say, hey, this user moved over there. And your history of posts, all that data that goes with you, doesn't go with you. And so you really lose that history because it's tied to that old identifier. And so one of the most interesting things that I think the Blue Sky folks are doing with the AT protocol is to separate this idea of who you are from what server are you interacting and actually going through. And so that separation is actually really, really critical and really interesting. And I said in one of the posts on Blue Sky, this reminds me of some of the problems that we're having with Docker containers. This is me sort of talking about my history here. But with Docker containers, if you look at an OCI container, there's essentially there's a domain name, and then there's sort of, stuff that comes after the slash, and that sounds great. Domain names and DNS are great for being able to actually have a naming system that we all understand, that is well managed, that has the history behind it. But one of the core problems with Docker containers is that you're given an ID for a Docker container. That name, that DNS name that's actually at the start of it, that's the thing that you actually reach out and talk to if you want to download that image, which is in a lot of cases really great. But what that means then is that if you want to do something like host an image across a bunch of different places, or cache it, or do all sorts of other things, you want to be able to separate the idea of identity, what is the identity of that image, from where is that image being served. So I've called this in the past identity versus discovery. Now, this is something that I brought up to the Docker folks early on, but it just kind of got lost in the thread. But if you look at Kubernetes, there was this big thing where the original repo for Kubernetes images was being hosted on GCR, which is the Google Container Registry. Huge thing to be able to actually rename this to something that was actually running under Kates.io. And there's infrastructure that needs to be run there to essentially play redirector to say, hey, if you're coming from here, we're going to redirect you to S3 if you're on AWS, or GCS if you're on Google or whatever. And so building in that idea of identity being different from sort of server is something that really is sitting at the core of what I think is really interesting about Blue Sky and AT Proto. So that's super, super cool. So folks are already asking some questions here. Yeah, so one of the differences is that and we'll get into this a little bit with the AT protocol, you can download your entire archive of your posts, and then you can go ahead and host those someplace else. And there's a way to be able to redirect between these things, which is actually really great. Right now, when you're using Blue Sky, all of your posts are hosted on a server that's being run by Blue Sky, but they're building all of the capabilities there so that you can actually host your own server or go to a different hoster, that type of thing. So really, really interesting there. Now, one of the things that I think is kind of interesting here is that we'll see that domain names get used in a whole bunch of different places in different ways. And we already see this. Like if you're a Java programmer, it's not unusual, or Go, to actually have your packages named based on DNS. And the reason we do that is DNS is a well-managed naming system. And so what we're seeing here is that we're using DNS both in terms of, describing where your services are hosted, but then also as an identity type of thing, which is actually really cool. Okay. So the key thing here, I think, is identity, which I think is really great. And then, the next step down here ends up being, okay, now you have identity for a user. How can you find that user's data, and what does that data look like? And here, I think, I hesitate to use the term Web3 because I think it's mostly BS, but there's some really interesting projects, things like IPFS, the Interplanetary File System, and this sort of, thing that got extracted out from under it called IPLD, which is the Interplanetary Linked Data, which is this idea around content addressable data, where you can take some data, you can then, based on the quality of that data, you can take an identifier out of it, and then you can start linking these things all over the place. And it doesn't matter where the data is stored, it doesn't matter where the data came from. If you have the content addressable ID and you have the data, you're good to go. So it separates out sort of how do you publish data and identify data from how do you get that data, which is really, really interesting. And then you layer on top of it with the identity system is how do you then verify that a certain person is the one who created or published that data? And so we have sort of these three concerns that have been separated out. There's the idea of identity and being able to assert that this identity created or published this data. There's being able to identify data in a location independent way. And then there's this idea of like, well, okay, now how do you go through and find that data? Where is it actually hosted? And so you'll see this as you start going through the AT protocol stuff, is that you have identity, you have the data repositories, which you can think about this as a zip file with all of your data. And we'll get to some of the nuances about how you do that. Then there's question of like, well, if you have a whole, how do you go through and start interconnecting these things between accounts? How does one account reference data in another account? How do you build an experience that actually works across all that stuff? And that comes down to this federation interoperability. And then there's this idea of, and I think that the amount of details in the spec and the amount of details in the code that folks are already looking at is relatively thin. This is still very hot off the presses, but there's this idea of, okay, now that you have everybody publishing their data, how do you then start providing things like indexing and search across huge amounts of distributed data? And so, one of the, analogies here is that, okay, how do we build web servers? But then there's this question of, well, how do we then build Google on top of it? Arguing by analogy here. So Russell Joy, says in the comments here that each individual part seems easy to understand, but then putting it all together is a challenge. And I totally agree here. And as I started looking at this, I'm like, oh, Merkle trees and all this stuff. I understand that, I'm smart, but you get into the details and it's like, well, this spec references this spec, references this spec, references this other thing. And there's this long chain of concepts and technologies that you really have to dig into to really understand this stuff. So that's one of the interesting things that I'm starting to dig into. And then sort of, what you see sort of layering on top of this then is algorithmic choice, right? If you have, if we have everybody publishing a bunch of stuff and then you have interfaces for being able to search and consume that, then there's room for being able to actually create choice in terms of how do you search, how do you consume, how do you display that data? And there's no one true way to be able to do that. And this is this idea of interoperability. And I think there's some interesting ideas there around just, going back to sort of a blue sky Twitter type of comparison here. Twitter has the blue check mark. That's what everybody's talking about. And the blue check mark is essentially a bit of metadata on an account. So Carlos is asking, can the PDS be a cloud managed service? Essentially, that's what Blue Sky is right now. It is a cloud managed service. But the idea is that you could then go through and have other people manage it, and it could be separated out. But right now, if we think about Twitter, that blue check mark is nothing but a bit of metadata on an account. So inside of a database somewhere in Twitter, there is an is verified flag of some sort that then goes ahead and gets set, and then that gets served through an API, and then some sort of client then displays that check mark. It's not inconceivable that we could actually then have something else, which is why is Twitter the only one that actually gets to write metadata about an account, right? In some sort of, AT proto or blue sky type of world, you could imagine that you have somebody who says, hey, I vouch for this account. They then publish that as a bit of metadata. That metadata then can get joined in with ranking, with display, with all sorts of other things. And so this idea of being able to take the published stream that people are publishing, join that with trusted data from other places, whether that be scores, of like how spammy is this, language estimation, like what language is this published in, is this in a verified account or what have you. There could be 12 million different types of verifications. You choose the verification, the check mark that makes sense to you, and then you can actually bind that into your algorithmic choice and your display, that type of thing. Yeah, a lot like cert bundles in some ways where it's like, but this idea that you can have somebody publish it and then you can have somebody say something about that, right? That's kind of what likes are. And that can be done in a trusted way so that you know that the person who published it is well known, and then the entity that is actually saying something about it is also well known, and then you join that together at the display level or at the algorithmic indexing level. But yeah, so there's that's I think where a lot of this is going, is these really great qualities around account portability, around being able to have a marketplace of algorithms and features or signals about posts and about accounts. But we're still very, very, very early in that arc of being able to develop that stuff. And I think, it's fascinating to see how much the MVP that the Blue Sky folks have built on has really caught on, and also how far there is to go for them to really fulfill the vision that they have of where they want to go ahead and take this stuff. So Carlos is asking, how does the verification and stuff relate to spiffy concepts? There's definitely some overlap here between the IDs and the DIDs and sort of what spiffy looks like. Spiffy was very much created with the idea of an enterprise production environment to be able to run this stuff in. But the theme that I'm seeing through a lot of this stuff is ultimately, and this is where crypto stuff comes in, is that essentially what you have is you have a cryptographic key that somebody created. They're using that to sign a bunch of data, and then there's various ways of being able to identify and publish that data, right? But ultimately, you need to be able to connect an identity to a key. And that connecting identity to key is an incredibly hard problem. Oftentimes it's called the secure introduction problem. And so one way of doing this is that, you can publish stuff in DNS, right? You can say, I'm going to publish my key in DNS, and you'll see a lot of the mechanisms for being able to handle spam go ahead and do that. One of the problems that we have is that DNS by default is not secure. You can go ahead and publish things on a well-known HTTP server using TLS. Well, how secure is that? Well, it's as secure as Let's Encrypt is, and Let's Encrypt is only as secure as DNS is. And so what you'll find is that as you start tracing where is the root of trust here, at some point there's a leap of faith, where it's like, this is the thing I'm going to trust. So if you use Signal to talk to somebody, you connect to them via a phone number, and you'll know that if they get a new phone or reinitialize Signal or something, you'll get a warning there saying like, hey, the identification number with this person changed. That's essentially a leap of trust. You'll see it with SSH and host keys, and the fact that GitHub had to rotate their host key a little while ago. And so, there's essentially a new leap of trust when you accept the new host key from GitHub. And so a lot of these technologies that we're looking at here, PKI and content addressable and all this stuff, super interesting stuff. But as you start figuring out where is that leap of faith, where is the root of trust that all of this stuff builds on, that's where you'll see systems like Blue Sky actually ultimately are rooted in more traditional ways of talking about this currently. Things like the TLS, right? You go to the Blue Sky server, and that essentially ends up being, you trust them to be able to actually tell you what the public keys are for a particular user. But a lot of the blockchain crypto folks, they think the root of trust should be the blockchain, which is essentially, a theory that nobody can actually overwhelm that blockchain, and that ultimately ends up with the funky math problems and people competing to and it ends up being an economic thing that actually brings the scammers. So there's a lot of these technologies which are interesting, but where you root the trust, how you actually do that secure introduction, how you associate identity with keys, ends up being very different across these things. And I don't think anybody has it totally figured out. I think as we start looking at what Blue Sky is doing right now, there's some hand waves and some stuff that is very rough and ready as we start tracing down this stuff. So Carlo, okay, so there's a ton of questions here. So right now, currently, and we'll look at this, is that the private key for the account is held for you on one of Blue Sky's servers. And this is essentially what they're calling the placeholder protocol for the distributed identifiers. And so let's start digging into that. I want to actually start showing. So like the idea here is that what we have is we have an ID in the domain, right? And then we can go through and we can look that up. So here, I'll show you what things look like here. Can you all read this? If you can't read stuff, let me know. Let me make this a bit bigger. Okay. If I do dig text of my thing on So this is my identifier on, oh, you can't see anything? Let's see, did it come through? There we go. Okay, it's coming through. Yeah, so I think what Ryan's saying here is that there is a leap of faith here. I think the thing that you want to do is be very intentional and very upfront about where that leap of faith is. Because if you're not, then all of a sudden people think things are secure, but they don't really map it down to, okay, what are the danger spots? Where can things go wrong? Where am I actually trusting stuff? I'll make this a little bit bigger. Okay, so what I did here is I did a DNS lookup on my name, my account that I'm actually using. Yeah, I'm gonna start doing the Blue Sky Go utility in a little bit. And what we're seeing here is that there is, okay, I'm not seeing. So there's a CNAME and a text record. What am I doing wrong here? So that when you go to Blue Sky, I'll show you what it looks like. I'm probably using dig wrong. Let's see what we have here. If I go to settings, oh, I have 5 invite codes. Somebody gave me some invite codes. I'll have to be very careful about those. Don't ask. If I go through and do change my handle, and I have, say I own my own domain here, what you can see, oh, I see. So it's the underscore AT proto. That's what I was forgetting here. So yeah, so if I do underscore AT proto, then what you see here is that we're using DNS to be able to map a friendly name, which is based on DNS, into this funny looking string here called did.plc here like this. Now this is actually an identifier here. So it's this scheme called distributed identification. And the way that this breaks down, and is that it's a W3C standard that's being, I don't know what the current status. It's a recommendation now, so it's actually getting more official. But this is a scheme which, and this is where there is some similarities with Spiffy to some degree, but this is actually kind of more generic. We could probably have a Spiffy method for DIDs, which I think would really be kind of interesting. Do I need to rotate the text? No, I don't. So that's totally public. Anybody else could go ahead and do that. There was nothing. I'm trying to be as careful as I can not to actually show stuff. One time early on in TGIK, I showed some credentials that were relatively easy to type in during the stream, and somebody started launching all sorts of wacky stuff on a Kubernetes cluster while I was doing stuff live, and it ended poorly. So I'm now a lot more careful about that. But the idea here is that if you look at the DID, it consists of DID, colon, and then this is called the method, and then there's an identifier that comes after that. And so it's you could use a UID as part of a DID, but DIDs have more structure in them. And one of the things that you'll see across a lot of the technologies that we have here that we're going to be looking at is that they can actually be a lot more self-describing. And so that's what the DID is. It's not just an opaque identifier. Instead, there's some structure to it. And if I can find it here, there's a thing, it's called the method, right? And so there's a whole registry of methods. Oh, and I had that up, but I don't know where it went. So there's the DID method registry. And this is essentially, how do you resolve that DID into a document that describes more information about that DID? Okay. And so this is one of those things that we're going to be taking a look at. Is this? Oh, the DID method registry. Here we go. So here's all the different schemes for turning a DID into more information about the DID. And there's more than actually listed here. So the Blue Sky folks created a new one, and they haven't published it here yet, and they called it the placeholder mechanism. And so that ends up being one of the things that I want to go a little bit deeper on. And so if we go back to the protocol here, if you start reading through this stuff, what you'll see is they point you at this thing called did.plc. And this is a way whereas essentially so we can go from DNS to one of these things. And then we can go from one of these things into a document that tells us a little bit more about it. And so I have here a utility here where I can go through and I can actually do did get with this thing here. Oh, wait. I have to do the whole string. And I'll get into a little bit more detail on what exactly is going on at the network level here. So this then actually then takes this string here, uses the PLC method or scheme, and then goes ahead and resolves that into this JSON document here. Let me send that through JQ so that we can actually get a little bit more clear of what's going on there. So the first step of all of this stuff is, how do I take a domain name? How do I turn that into a DID? And then how do I turn that DID into this document that we have here? So I'm going to read through the comments here. And so this is essentially a way to turn that identifier into more information. And then from there, you can bootstrap all sorts of other stuff here. So the PLC one is supported by the, and this is what Ryan's saying, by the Blue Sky folks. They also support another scheme, and I have that page up here, and I'll drop all these into comments afterwards, called did::web. And this one is actually really pretty darn simple. It's essentially saying, you know, take the, so I could do, for did web, I could have something like, they have some examples here. I could have, you know, something like did : you know, web : h.oli. So that actually is a did using web. And what that's essentially saying is, oh, to get this document, make an HTTPS call to that domain name. And either you can have like, you know, foo, like where you have users like that, or you can do the .well-known trick. And so it essentially turns this into an HTTP call into the server that you're hosting, which is great. But then we break one of the things that the Blue Sky folks really wanted to do, was say, hey, you can use your own domain, and we want to separate out where is the hosting going on from who is the where's the hosting versus where is the identity mapping going on. Now it turns out that the did web stuff is actually not that hard. It's just really putting, you know, what's mostly a static file there, but you have to update this did document anytime you rotate your keys. And so I think one of the things that we've learned through history with cryptography is that if you don't have an easy automated way to rotate your keys, you're not going to rotate your keys, and things are going to leak and they're going to get broken. And so I think one of the weaknesses with the web method for DIDs right now is that it's very difficult to integrate that with things that'll automatically rotate your keys along with it. And so there ends up being this dance, I think, between things that are using the keys, which is what we're going to see with the Blue Sky actual sort of methods here, which is the AT Proto personal data server that you're seeing here. Things that are using those keys versus being able to rotate the keys and then publish that you rotated the keys. Those are all sort of this fine-tuned dance that has to happen. That's a lot easier with something like the placeholder method that they have versus doing something like a static document on a website. But there's going to be a lot of room for this stuff to evolve, and I think it's really fascinating. There's this long history of, like, you know, programmers and people, engineers working on this stuff, where you do something, you know, it's a temporary hack, and so you give it a name like placeholder or hack or insecure, don't use this. You'll see command line flags. You'll see this in protos where it's like essentially like, this thing should not live for a long time, so I'm going to give it a really crappy name. That's not a guarantee that it's not going to live for a long time, but that's at least it's at least an indication of the idea of like, yeah, this sucks. We don't want this stuff to actually live forever. So key rotation activity pub Yeah, that's definitely there's an interesting thing with like the 72-hour grace period. Sort of like if your account gets compromised, you can rewind some stuff and sort of like go back to where you were. That I think is really interesting in some of the stuff with the placeholder method that we have here. So yeah. So that's so now what we have here is we've taken an identifier that's DNS based, we've turned it into a DID, and then we've turned that DID into a document where, it's essentially a JSON document that we can do all sorts of interesting things there. So Carlos is asking, what's the relation with ActivityPub and AT? I don't believe there's a relationship. I'm sure, AT came later. And so there's probably learnings and lessons that have been imported, but I don't think that at a technical level that those things are connected at all. Now, one interesting thing that I want to point out here is this right here, also known as. So now what we have here is that the DNS entry points to the DID that provides a way, whether it's PLC or web or who knows what else into the future, provides a way to resolve it into this document. But the also known as actually then provides a back pointer to the DNS based name. And so these things point at each other, which is really a level of verification that we need. And so this means that I can't create a random domain name, which is like I'mANazi.com, and then point it at somebody's account, because they then would not have their DID document point back to I'mANazi.com. And so it's then up to servers and clients to be able to, people who are using these things, to be able to verify that round trip, that these things are fully interconnected. But at least there's that capability of having these things talk to each other and actually be able to cross-verify. So Russell says, surprised this documented return doesn't have versioning. That is kind of interesting. One of the things that I think we find here is that versioning these things is incredibly difficult. So Michael Hungers, so this idea, because and as we look at the serialization and sort of the schema work that the AT Proto folks did, they're essentially saying that, once you publish something, you really can't change the schema of that. And that's a really deep topic, but, you're going to find that if you extend the schema, then there's things that won't understand the new things. If you restrict the schema, then, and delete things, then people might publish stuff and it won't be understood. If you have a new version, then oftentimes what you have is the necessity to be able to convert between the different versions, because you want old clients to be able to use new things and back and forth. So that stuff ends up being really tricky. And if you look at sort of the history of Kubernetes and the API server and versioning things like CRDs, it is a rabbit hole that does not end. It's really painful. So Ryan's saying the data model has a version field in the commit records that's statically set to. Okay, so maybe there is some room for things to be versioned in the future, but that's a really good point. Okay, so Carlos is saying, why didn't they put this doc in the DNS text doc itself? That's a good question. I think the biggest problem there is that there's a limit to how much data you can serve off of DNS. It really just wasn't built for large amounts of data. And you'll find that if you do some sort of spam stuff, there's places where they'll put stuff and they'll actually sort of spread it across multiple text records. But at some point we may get to the point where, there's tons of services. This document could grow very large over time. And I think that would be a good thing. That would mean that there's more and more things that are associated with your DID as it becomes sort of a primary sort of identity point for you on the internet, which is, I think, I haven't fully grokked where that stuff is going, but I think it'll eventually get there. So earlier on, Michael was saying, how can we ensure that the back pointer from the DID document to the domain happens? That'll happen automatically as you go through the registration process with Blue Sky. As we look to this stuff getting federated and disaggregated, that's going to be one of those things that, you're going to have to make sure, or whoever's actually helping you to host this stuff is going to have to make sure that there's good back pointers here. The DNS thing is entirely outside AT-Proto's documented DID-based identity scheme. So the DNS, there is, as part of the identity here, this idea is AT here, that the also known as is actually part of the protocol there. So those things do actually, I think, loop together. And there is, however, another method here called did DNS, which is essentially, like we were saying, how do you host the entire did document in DNS? And it's spread across multiple records. And then as you read those records, you then go ahead and can create the did document based on that. So everything's existing in DNS, but it's just really janky when I look at it, and you're going to end up using a ton of DNS records. And the way that you do it is that you have to list all the DNS records and then iterate through them. So the whole thing is just kind of like this DNS thing is kind of wonky. I do think it would be interesting to actually have, and I'm sure somebody has thought about this, a did method that would be like a proxy, which says like, hey, I want to, proxy to this other thing, and then you could change it over time. I don't know. Like this stuff gets hard, I think is what we're saying. But the idea is that the flow here is that we get from a domain name into this document, which is great. This document, then the two key pieces of information that we have here is this public key here, and the service endpoint, right? So this is who is hosting my data for AT-Proto, and then this is how can you verify that stuff that's published is really coming from me. That's what that key is actually saying. Now this public key here, this looks like a random string, but it turns out that this thing is, oh God, as you start digging into this, I had that tab up. I believe, when you see this like public key multi-base, this is essentially a serialization that if you know the right scheme to be able to decode it, it actually then describes as part of it what is the algorithm that's being used to actually describe that public key. And so a lot of that stuff ends up being, yeah. So Michael, after I'm done, what I'm going to do is I'm going to take all of my tabs and I'll just copy and paste a bunch of links into the description of the video as I'm pulling this stuff up. So I think, I don't know if this thing is a CID or not, but we'll get into that. But there's this idea that even though you can't see it here, this string is to a certain degree self-describing, which is really interesting. So in a lot of places across this whole world, we're moving away from identifiers that are very opaque, where you have to know something about them, to identifiers that are much more self-describing, where they're able to actually talk about what they do. All right, so now we have an identity. We have this server here. This is where AT-Proto really starts to come in. And so if we look at this, one of the key things that is really about AT-Proto is this idea of a data repository. So you know how like when we were all scared that Twitter was going to like die at any minute, you went through and you said, hey, Twitter, I want to download my Twitter archive. And then you would go ahead and you would get this zip file that had like all your Twitter data going all the way back. That's essentially what this archive is. But instead of being the sort of like half-ass mess that the Twitter archive really was, this is something that's cryptographically sound, where you can actually verify through time. And so in the same way that it's very, it's impossible without breaking the, cryptographic hashes to be able to change history in a Git repo without it being obvious. Same sort of thing. Very similar coming through the what the AT-Proto is calling the personal data repositories, PDRs. And so these things are actually laid out as a Merkle search tree, and there's a paper there that you can read. I haven't read it yet, but essentially what this is it's a data structure where you have a root, And then based on that root, there's a whole bunch of other data, and there's cryptographic, hashing all the way up, so that if something gets messed up somewhere, you can go through and actually detect it. And by looking at that one final hash, you can detect whether everything is valid or not. Now, this is where things start to get really deep. So each node, which means that each one of these objects is this thing that comes from this IPLD project, which is that thing that got extracted, I believe, out of the Interplanetary File System, IPFS. And so there's a whole bunch of documents and stuff going on here, and types of ways of addressing this. But the two things that we have here is we have this DAG-CBOR thing. So this is where I said there's just this sort of like, this random walk of specifications that I haven't already gone through. This is a way of being able to create one of these trees that link to each other, and then being able to serialize these. And then this is actually based on this thing called the concise binary object representation, which is this other spec, which is essentially a binary way of like being able to encode JSON-like data. There's alternate versions of this that use protobuf or JSON itself. And then each of these objects and everything in this world is actually identified using this thing called a CID, which is a content identifier specification. And if you go and look at this, what you'll see is this uses a essentially encodes in it the fact of what it is, what the version of it, whether it's a SID v1 or a SID v2, what the codec is, and then a hash that actually reads over that stuff. So there's just a lot of stuff here. Now, one of the problems that I think you'll see across anything that's content addressable is the fact that that many serialization formats are not normalized. And what I mean is that you can take the same data, and depending on how you save it or operate with it, something that's logically the same could actually be serialized multiple ways and then lead to multiple hashes to be able to be on it. And so this could be something as simple as Unicode. Unicode is actually very difficult because there's non-normalized versions of Unicode which will display the same, but under the covers, there's extra bytes and there's extra stuff going on in there. If you take a JSON document and you just naively process it, what you may find is that if you have a map, the order of the keys in the map as it gets serialized is not guaranteed. And that'll change the hash as you actually try to do content ID type stuff. Same thing with tar files, same thing with zip files. Even things that not obvious, but like one of the sort of holy grails for a lot of supply chain stuff, and by supply chain, I mean like being able to identify where and how software came from, is the fact that compilers are not it's another type of serialization to some degree. Compilers are not deterministic. Oftentimes they'll stick things like dates of when things were built in there. And that means it's very difficult then to be able to identify that, hey, I had the same input, I got the same output type of thing. If you rewind the clock a little bit, I think the first time I saw this problem being addressed was with Nix, which is this very reproducible hermetic build system that I think is getting a second life right now. Really interesting stuff. And so as part of Nix, they had a format called NAR, which is the Nix archive format, which was this idea of how do you take a bunch of files, stuff them together into a single file, and do it in a way that's repeatable and stable so that you can do content ID. And so one of the things that in this world with IPFS and IPLD is this specification called the a car file. And so if you look here, it's a transport. And so the car file is a canonical representation. So how do you take a bunch of objects and then serialize all this stuff in a very repeatable, predictable way so that then you can take a hash over it and use that hash as a stable identifier. And so it's easy when you're thinking about, okay, I have a JPEG file or a GIF file or whatever, and I want to do a content ID on that. But once you have structured data that you want to be able to serialize and deserialize, that's when this stuff actually, I think, gets pretty tricky. So the next thing I'm going to do here, so let me then go through, and if you go through and look at the Blue Sky GitHub repo, There's this project called Indigo, which is a big bunch of their servers, and and sitting in here is a bunch of useful libraries, but there's this command called Go Sky, which is essentially a sort of low level. Yeah, I wish there was GIF support in Blue Sky now, but this is essentially like a low level debugging thing to be able to explore some of the capabilities. It's not as fully features that as I would want it to be, but we'll get into that a little bit. So one of the things that we can do here is if I have this stuff built, so you can go ahead and build it, is you can see, okay, here's what we have, and there's a bunch of commands. This stuff is, like I said, not complete in any way. One of the things that I did is that if you do create session here, that there's command line, and for some of this stuff you have to read the code. So if we go through and if we look at Go Sky main, if we look at this, you'll see that your handle and the password are the two things there, and that's not documented anywhere else outside the code. If you do that, that'll spit out a file. You put that file into, I'm not going to show it to you because it can be used to take over my account. You put that file into something called bsky.auth, and that's the thing that I'm using to be able to authenticate to the server. Oh, Rags, yeah, so you put a PR to add the positional. Yeah, it's a total pain in the butt. You have to splunk through the code to actually be able to get to this stuff. But I went ahead and did that. And so now I can actually go through and I can do Go Sky. And then the next thing I can do is I can do handle. And what this does, not handle. Resolve. Okay. And this then goes through and actually resolves this handle into the did. So this is actually just a DNS lookup. Now it turns out that this is making a call under the covers to one of Blue Sky servers to be able to do this, mostly probably because they do a lot of caching and such, and it also probably works around issues with DNS propagation. They may update their map when you change things before DNS just totally propagates. But logically, this is essentially doing that DNS lookup for you. And then from there, I can go through and I can do, I had this did get, which actually goes through and then goes ahead and gets that document. Now, this is actually what's happening when I do the did get, is that it's looking at this PLC here and saying, oh, for this type of method, I want to be able to talk to the server in this way, and it's going to pull from its own database to be able to give me this information. And there's a whole sort of like, transactionable log that goes on with the placeholder protocol there. But now what I can go through is I have this information is I can go through and actually get the repo. So let me see if I can find. So there's two different, if we start looking at it here, I'm skipping over some of the other stuff, but there's two different services that they have. There's repo, which is mostly around sort of updating records in your repo and listing records and stuff like that. And then there's sync, which is essentially a cross-server sync. So one of these things is really how do you actually update and use the repo from a client, I think, and the other one is server-to-server stuff. The sync versus repo stuff seems kind of confusing for me. So Russell's asking, does the Go Sky contain the PLC logic, or is it reaching out? It's a relatively thin wrapper that reaches out to the Blue Sky server to be able to do that. That particular server is open source, and if you go here, it is, so they have documentation of did method PLC, but then if you look at all repositories here, I believe, oh yeah, this one is actually the server here. And so you can dig into this. It's written in Node, this particular server for doing the did stuff. Okay, yeah. So the repo methods are client server, and then the sync methods are server to server. But one of the interesting things that we can do here is I can go through Go Sky and I can do sync, and then I can do get repo. So there's a couple of interesting things here. So I can do list repos, and this goes through and gives me every did that Blue Sky on the Blue Sky servers. This probably won't scale, but essentially I can say, show me how many accounts are actually on the Blue Sky servers. But one of the things I can do here is I can do get repo. Let me make sure. Okay, and then I want to do raw. Well, I can do it without raw, and then I can have, oh, I need my did, which I've lost because there's my did. Okay. We'll do my did equals that. Okay. Get repo. And this is essentially, and it's writing it out in sort of a, ASCII friendly way, but this is essentially my total history on Blue Sky. And this stuff is I believe everything in here is public, but I can do raw and I can do, my repo.car. And this is actually, I wanted to redirect that. This is actually one of those content addressable archives that actually goes there. So how do you install GoSky? What you have to do is you have to do the Indigo repo and then go ahead and build that. There's a make file there. And so as long as you have, the right version of Go installed, it was relatively easy to actually get that up and running. And then it just drops the binary into the root of your of that directory. All right, so now I have this file called myrepo.car. And so one of the questions you may be asking is, well, what the heck can we do with this file? How can I actually go ahead and look at it? And it turns out that the tools suck right now. I spent all morning trying to figure this stuff out, and I couldn't find a tool that's actually really good at being able to dig into and visualize what's going on in this car file. There is this command called go car, but that is not it. IPLD. Yeah, so there is this thing here, this utility that lets you go ahead and mess with, but it only can take you so far. And there's actually a protocol that the Blue Sky folks are using that GoCar doesn't actually support. So I can do GoCar, which is this. What's it called? Oh, it's just called car. So I can do car, and I can do inspect my repo.car. So we actually say this is a valid version 1 car file. And, I haven't dug in too far into this, but you can actually say like, okay, how many records are in here? I think those are the blocks. And then there's this idea of that root, sort of this, this is a content addressable archive. There's a root to essentially the data structures there that you can actually go ahead and look at. And then you can go through and you can do things like, go car, and then you can do list car list my repo.car. These are all the content addressable IDs. These are all essentially the data items that are in that car. And now I can go through, and if I remember correctly, there's a couple of options I can give here, which are verbose, myrepo.car, and then this says that each of these objects here, the encoding mechanism of this thing is called dag-cbor. Yeah, and so one of the problems that we have here then is that this utility here doesn't support dag-cbor. It only supports dag protobuf, I believe. And so I think, it's one of these things where, interoperability is supposed to be there, but like there's different choices and these things are coming along. And so I haven't found a good tool, at least searching this morning, to be able to take this car file and being able to really visualize what's going on there. But that's essentially when we talk about being able to take your data from one server to another. That's essentially what we're talking about. That is my data. I can take that, and as long as, I have the right keys, I can go ahead and start publishing that and updating that someplace else, which I think is really interesting. Now, you could build a service like Blue Sky where you go ahead and you download these car files for all of, a whole bunch of users, and then do all sorts of processing of that stuff on the client side. Uh, but it turns out that that's a lot of data, that's a lot of traffic, and it's a lot of code that's running client side that, from a distributed system sort of app point of view, if you have a bug there and you're doing something bad, you have a bug in a lot of places. And so I think in systems like this, my design sense is try and keep the clients a little bit on the simpler side and try and move a lot of the sort of the nitty gritty logic into the server, because that's a lot easier for you to update and actually be able to change. And so then what the Blue Sky folks did on top of this is that we have this data model. This data model is cryptographically sound, or at least in theory. You can download it, you can move it around. But if you really want to mess with it, if you really want to play with it, there's a whole bunch of objects in this repo thing. There's a whole bunch of methods here that really let you go through and interact with these things in a much more fine-grained way. So instead of you downloading that archive and being able to mess with it, you let the server actually keep a cache of the archive, decompose it into things that are much faster to serve, create the connections between them. And so there's methods here that operate on the underlying data model that you'll see in the archive. But they are not sort of mucking with that stuff directly. You're essentially trusting the server to interpret those files for you. And so so the client generally doesn't work with the PDS directly, but instead uses the Blue Sky server, this set of repo methods to be able to interact with the PDS directly, or at least that data structure. So how do PDSs fall back if they don't understand a certain lexicon yet? I don't know. That's a good question. A lot of times what happens, so let me back up a little bit here for those who haven't, I'm just going to talk a little bit about this. So we have this data repository. We're storing a bunch of data. That data is content identifiable. It's a bunch of records. We have roots, all great stuff here. It breaks down into things like you have your root, which is like the account. You have collections, which is like a set of feeds, but other collections might be likes or the people that you're following. And then there's individual records that are there. So this is the general data schema that actually gets encoded into that car. I wish I could give you a better visualization of that than I can right now. But then the idea here is that, like, okay, we have things like this, right? Record types, posts, like how do we describe the data that's going on in those things? Now, ultimately, these things are, stored in JSON-like objects. But then the question is, how do we identify the schema there? And so this is a system that the Blue Sky folks came up with called Lexicon. And Lexicon is essentially a schema system for this stuff. Now, this definitely to me feels like yet another schema. And so I'm a little bit unsure on whether the world needs another schema here. I assume that the Blue Sky folks had a good reason to be able to do this. But one of the things that smells bad to me is that if you look at sort of like, here's the schema for the schema, right? And we're kind of deep in here, but the schema for the schema, it's like, well, anything that we're describing something that's a query, a procedure, a record, or a token, apparently, are the four types. But then they have things like, well, they have comments here saying, well, these fields are only... So in some ways, their schema is not powerful enough to describe their schema language itself. And so there's a little bit of like, yeah, and Brian's here, like, aren't we getting awful close to XML? Yeah, I mean, this is thing where it's like, JSON is beautiful until you need to actually operate and validate with it. And then you need schemas, and then you're pretty much back to a lot of the stuff that we were back to with XML. Now, one of the things that XML did that I think added a ton of confusion was the idea of being able to have multiple schemas used in the same document. And so you ended up with things like, namespace tags with namespace mapping, and each of those things could then point to a schema document. And I think that composability of having multiple schemas being able to compose into a single document added a ton of complexity. Like the XML libraries for Go are just god awful bad and have it all wrong. But I think that there's there's something to be said for schemas here. And I think we're definitely, JSON not having a standardized schema that is just the way means that we end up with issues like lexicon here. And the places I think in the sort of JSON world where you might want to compose schemas, I think generally people just break that into separate documents and you sort of point from one document to another. And so that's, I think, an interesting aspect of sort of how sort of the XML JSON stuff has evolved a little bit. I see this stuff and I think about some of the config languages, things like, oh God, I'm blanking on the name. It's one of the cool, oh God, it's the folks who did Borg config are doing it. And it's the thing that Solomon's doing his startup around. So what he's doing, what's his Dagger, right? And they're all based on, yeah. So Dagger is based on this language. No, not that Dagger. Oh, wait, yes. Or maybe they moved away from it. Q. So QLang is really interesting, which is essentially both a serialization, of JSON-like data, but is also sort of has schema mechanisms built into it. So I think it's yet another aspect of this that I think is really interesting. But regardless, where we're at is that there's yet another way of describing JSON schemas that is used in AT Proto. That is this thing called lexicon. And then they also built as part of that a new RPC framework called XRPC, which is in some ways very similar to Wire Protocol, kind of similar to gRPC, kind of similar to something like the XML RPC. The difference from something like REST is that with REST, if you're a purist, you go through and, you only have, get, put, delete, and update. Whereas I think, RPC like things, you have methods that are named. And so this is definitely in the RPC vein where essentially instead of just viewing things as resources, you actually have arbitrary methods that can operate on arbitrary things. In some ways, when you look at this stuff, and there's this old technology that's been around for a while called Hate OAS. I don't know how you Hypermedia's engine as the engine of application state. In some ways, like we're still sort of taking a bunch of these ideas, and GraphQL also, of like how do you go through and create interlinked data structures that can point to each other. And so this is some sort of very early prior art that, and this goes all the way back to, the world of things like Corba and stuff like that. But in some ways, like a lot of this stuff just gets reinvented and recycled in a lot of ways, but it is what it is. There's always trade-offs to be made across this stuff. So I'm not going to go into a lot of detail, but the idea is that you have lexicon, which is a schema, and then you have XRPC. And then when you come down and you look at things like this atproto.repo, this is essentially a bunch of, schemas for XRPC calls that are encoded using lexicon. I think I used all those words correctly. So lexicon is the schema, the protocol, the wire protocol is XRPC, and then they call these things lexicons, which are essentially the schema documents for these things. And so, in this way, they're kind of using, a lexicon is not just a schema, it's also kind of an IDL. IDL stands for interactive data language. It's essentially these ways of like, how do you, meta describe protocols and schemas and stuff like that. So, and this is one of those interesting things where whenever you're doing something like AT Proto, you have to choose where are the things that you want to go through and reinvent the world and do something new? And where are the things where you're like, hey, this thing sucks, but it's well known and I'm going to get other stuff done. Right. And so I think, yeah, JJ, like daggers based on Q. Yeah, I got there. And so like when we were, when I was doing Spiffy early on, this was before a lot of the Jose Jot stuff was there. It was this idea of like, hey, we need to be able to, publish and consume public keys and stuff. And I looked at it and I'm like, everybody hates X509 certificates, but X509 certificates are well understood and well supported. So let's not reinvent it, but let's actually leave room to be able to replace this stuff later. And so, so I think, from a design point of view, I think reducing the number of new technologies and new, concepts for something like this is actually a really good thing. And I would not have introduced Lexicon and XRPC if I were doing this. But that's, neither here nor there. I think, for Blue Sky specifically, we can talk about the protocol all we want, but the thing that's really driving them right now is community and experience with their MVP. And all this stuff is very future looking in terms of whether it actually matters or not. Nobody hardly is actually signing up to Blue Sky right now because of AT Proto. I think it's one of the things that they're really building as they look towards the future, as they actually really want to build the world that they want to live in. So yeah, I'm going to go into a little bit more detail and then I should probably sign off. But like playing around with the Ghost Guy client is actually really fun, because then what you can do is you have ways to go through and let's see, let me find the Ghost Guy code because the help on this thing is very rough. But I can go through and look at like my feed, right? So let's go ahead and actually get my feed. Where is it? Feed. And then I believe that, see, now I have to like feed get. Name feed, Rod URI's author, to do, self did. This was working. I had this stuff working before. What am I doing wrong here? Hey, Brian, thanks for joining us, man. Good to see you. Oh, and the other Brian, good to see you. We got two Brians, but yeah, I think it's fun just to sort of like be able to just sort of riff on this stuff. But let me go. So this is bad request. I don't know what I'm doing wrong here. I want to get this thing going. Come on. Feed command. Okay. Pretty print post. This was working earlier for me, so I don't know what I'm doing wrong here now. So I can do list. And okay, and this ends up being then all of my posts. So I'm listing my own data there. You can give it a -- all. And you can actually see, well, now this is all my follows, all my posts, and all my likes that are actually all in that archive. So you can see that there's ways to be able to start breaking this stuff down. Now, this isn't operating directly on the car, but it's actually operating through the server that's operating essentially on the data in the car. For Ghost Guy, the only thing I need to do is run make build. You probably have to have the right version of Go installed. That's always a little bit tricky there too. Rag says that this can operate on the car. You just have to give it the right file path. List all posts. I don't think so, because this is actually going through and just getting the, now this goes through, it gets the repo. Oh, here we go. If I give it the file path. Okay, so now I can go through If I do, oh yeah. So now instead of giving my did, I gave it the car file. And so it's actually going through and downloading the repo and going through, and then essentially there's a whole bunch of stuff to be able to crack that repo and be able to filter it by posts and then be able to show stuff. And then we can actually then go through and we can also do values, and you can see, okay, so now the type here is a follow, and that shows me who I followed, their did, right? And then when I followed them. And so all that data of who I followed and when, here's all my posts, and then similar data for likes coming up here. Oh, got panic unreachable. Something happened, bad blob. So something's going on there. But yeah, so all that data is actually sitting in the car. Yes, you also have to generate the bsky.auth file. So the way that you do that is you do, I'm not going to look through my history because I probably have my password there. You call create session. And then the first parameter there is your account name at Blue Sky. The second one is your password. And then that outputs a JSON file, and you want to save that. You want to redirect that and save that into bsky.auth. I have a mute. I muted one guy who was being an ass to me, but I haven't done any blocks yet. So that may be in there also. And then similar, there's methods to update and actually add to that. So this really ends up being, yeah, I could do the app password thing and actually do that. Yeah, I ended up using my real password, which I probably shouldn't have. But yeah, I think, that is sort of the default sort of like mechanism of how this stuff works. But if we look at the feed here, you'll see like here's, again, it's like there's a lot of data there. So they've actually created in this lexicon, as you get a lot of data here, there's ends up being more specific data for both interacting with the server, but then also this stuff, I believe these types end up getting used for, I would like to see it. So one of the things that I think is kind of a little bit wacky is if I go through and if I look at repo here, I can get records. So let's see if I have like list records. So this essentially lists all the records, and you can see that the definition of a record is type of unknown. And so like they don't have the schema for essentially what a follow is, right? This thing actually, I think, is not at least documented in the same way here, because this is app.bsky.graph.follow. Maybe it is. Okay, yeah, no, here it is. Okay, so this is a record type. And so this is a place where this thing is not a method that you can call in the server, but rather it's a record type that gets serialized into PDS, into your PDS. And so they can add more data to this over time, but then there's ends up being a query where you can say, well, who's following this person? So there's procedures and queries, and this actually ends up being the data. And so the schema for the stuff that we saw here is all here. And so then really this just becomes an app of being able to update these data structures and be able to ask the server for that data back, or have the server be able to aggregate or, essentially do deeper queries for you. And so you'll see in here a lot of methods with things like create invite. I'm assuming that you can't call those things because they're going to say, hey, you don't have permission to do this. But the way that, you build systems like this is that, oftentimes, there's one philosophy where you build a management portal and you build a management API, an admin API that's separate from your public API. And then there's other places where you just throw it all together, and whether you get access to the certain methods or not is based on permissions. Because this is open source, because it's meant to be federated, having the admin and the sort of the usage API be in the same server and the same API probably makes some sense. If you were doing this commercially, you would probably have things like create invite be a separate API for just admins, and you would never actually expose that to somebody on the, publicly. So what I do like about this, and I think the really interesting thing here, is that right now we're talking about PDS, which is the data that you publish, your likes, your posts, the people that you're following, your blocks, your mutes, all that stuff is being published right now. And so the actor in this world is a person, right? A person who's actually going through and interacting in a Twitter-like way. There's room for this whole thing, including the sort of the data documents, to actually be published in different ways. Like imagine that you actually have, somebody who is like trusted verifier, right? So like, let's say that you have a community, that community is, you want to have a stamp of approval of like, hey, this person, hey, Ryan, good to see you. Have a good time, man. I'm going to probably wrap up in the next 10 minutes or so. But you want to be able to have somebody assert that like, hey, this person is verified for our community. Well, that community could have a DID, and they could then publish, instead of publishing posts, they could publish essentially verification records. And then those verification records can then be published and secured the exact way, same way that you secure and publish your posts. But then that can then be ingested by servers and then used for things like ranking and algorithms and display along with that. So this idea that, any object here in this world, and a post is an object, any record, you can actually has an ID, and then you can publish stuff that references that ID, opens up the world for, essentially you could buy, for instance, maybe there's a service that goes through and actually does translations of these things. And, you could buy that service, and then, the translations could be annotated on top of it from the outside. Hey, Alexi, good to see you too. And so you can also then go through and, maybe somebody builds a score of like, hey, how toxic is this post? Well, toxic, what does that mean, right? Toxic means different things to different people. Well, you could have different people with different ideas of what toxic is. They can actually then have that could be a feature of essentially a metadata that's assigned to a post. You could then subscribe to different definitions of toxic, whatever that means to you. And then you can apply that for your filtering, for your blocking, for your algorithmic resurfacing of stuff. And so this composable world of records plus metadata plus algorithms plus presentation, I think is really, really interesting. And I think we're still very much on the start of this. Yeah, Julia's saying on a scale of 0 to toxic, Britney Spears, how toxic are we? Now, and then, and one of the other interesting things is that, we're talking about this from the point of view of social media posts, but bringing this full circle to things like containers and Kubernetes, which like my mind is always there in some ways. Like when we think about secure supply chain, you publish a container image, and that container image may have something like a CID. Right now we have a Docker ID, right? A OCI image ID, but you could then encode that into a DID, right? So we could actually rationalize DIDs and container image names with the same sort of mappings for DIDs. And then from there, you could actually have that be content addressable. You could have the content addressable ID of that thing be embedded in the DID itself, which would be a good thing. But then things like tags. Tags are mutable, right? That mutable stuff could be something that's actually written from the outside. Things like, hey, this is past this, this vulnerability scanner at this time. That could be a piece of metadata that's not written as part of the image itself, but is actually coming from a different repository that's actually keying off of that content ID. Things like, hey, this has been approved for deployment into highly secure areas for my enterprise. So, that's the type of thing where this idea of having objects and metadata being published in trusted ways and then late bound and policy decisions being made on them, I think that's really interesting. And it actually applies both to the social media space, but also actually applies to, I think, a bunch of other things where trust and reputation and hard decisions of should I actually trust this thing? Is this good or not? Right? Is a really hard problem. I think there's a lot of interesting shared ideas and technologies here across this stuff that I think is pretty exciting. Hi, Angie. Good to see you. So with that, I think my voice is getting a little tired. I've been going for an hour and 15. Hopefully this is a good sort of really deep dive at the technical levels of like, what is ATP? What are some of the technologies it's built on? We didn't get to the point where you can go through and do a post from here, but you know, if you start digging into the Ghost Guy utility, you'll see that there's methods for being able to create posts and stuff like that. If you're writing Go code. Oh, and Brian says he's going to live stream next week. All right, man. Let us know about it. I definitely will watch. If you need help with OBS, let me know, because it's a total pain in the ass. Mike's asking if I'm considering going over the BEB. I don't know that one. I'm just learning about this stuff. So, yeah, send stuff my way. I think this is all a really interesting space. And I love to see usage of this stuff that is separated out from the sort of the crypto world, where there's always under you know, all this a certain level of scamminess. I apologize if you're deep into the crypto world, but like, I think it's great to see these technologies have a life that's outside of, you know, get rich quick schemes, which I think is really cool. So, all right, with that, I'm going to sign off with y'all, and then I'm going to take all the links in my tabs, and I'm going to put those in the description. And feel free to send anybody this link, and they can watch the video on demand. I recommend you do it at like 1.5x. But thanks for joining me on this Sunday, and I hope everybody has a good rest of the weekend and a great week next week. All right, talk to you all later.